Well, thanks, Meg, and thanks, everyone. It gives me great pleasure today to talk about the fertiliser value of manures because ever since I was a little kid, I've really liked talking about turds, but I've always been told it's socially unacceptable. And so to get a personal invite to come and talk about this stuff, it's pretty much like all of my Christmases have come true. All of my Christmases had come true if I could make this move too. Hey, there we go. Sorry, Meg. Make you come up and do that. So before we take a deep dive into the turds themselves, I might introduce the project team and let you know a bit about our project more broadly. So we have a couple of guys from New South Wales DPI, Mark and Graham, Hayden Thompson from FarmLink, that's our grower group that are involved, Julie Cattle from New South Wales EPA, myself from Southern Cross Uni and Abe Gibson, and our student Mariam Barati. Unfortunately, a lot of the team weren't able to make it today. The only one other than myself is Abe Gibson. You'll see him round, say g'day. He's about my height and with one of those sort of sexy moustaches that you can only get away with if you're born after about 1990 or if you're Italian. But go and say g'day, and he's round and about. So we have a few aims of our project that aren't just related to the fertiliser value of manures. As Meg suggested, the program itself is mainly about developing new products, and so we aim to look at how manures act in soil and affect nutrient cycling and priming, and how we might further develop some products out of that, and Mark Watmuff is looking after that part of the project. We aim to graduate a PhD student, and of course, we want to look at the fertiliser value of manures. And the reason we want to do that is because a lot of the farmers said, oh, that's fantastic that you want to get us some new products, but right this second, we've actually got a resource on our doorstep and we'd like to use it, but what's it good for? Like, can you tell us how much should we put on? What's the actual fertiliser value of it? So while the project aims to develop some new products, we thought we'd also address something that we could give to the farmer group straight up, which is what is the value of fertilisers and can they just stick them straight on as a replacement for normal fertilisers? So we don't go near human manure in this project. So there's a couple of reasons for that. There's two types of human turds. The first type is euphemistically called biosolids, and there's already a few programs in the CRC looking at biosolids. They're difficult to deal with because they've got a lot of, or can have contaminants, heavy metals, PFAS, so we stay away from those human turds. And the other human turds are, of course, just human beings that are pretty unsavoury characters and are just human turds. And as a project team, we really don't want anything to do with them either. So we very much stick to animal manures. All right. We're going to focus on phosphorus, and there's a good reason for that, other than the fact that I have an unnatural obsession with phosphorus as a nutrient. There's a very good reason we should focus on phosphorus in manures. A lot of people, or traditionally in Europe or where there's been access to plenty of housed animal manure, have applied manures as a nitrogen source for crops. And that creates problems because the ratio of phosphorus to nitrogen in manures can actually get down to about 1 to 1, 1 to 2 to 1 to 1. So in other words, there's a lot of phosphorus for the amount of nitrogen. Crops, on the other hand, have about 5 to 10 times as much nitrogen as phosphorus. So if you keep putting on manure to provide nitrogen for the crop, what's going to happen? Someone sing out. You're going to build it up. You're going to get a phosphorus build up in soil, which is all right if you've got a completely deficient soil to start with. You'll end up building fertility. But if you keep doing it over and over again, a couple of issues. One, if that soil erodes, and we heard this morning about some of the rates of topsoil erosion, if that soil then ends up in a river or in the ocean, you're going to get eutrophication. And two, and this has happened in some places in Europe where there's just a vast excess of manure, you can actually fill all of your phosphorus sorption sites, the binding sites in the soil. And from that point on, you actually get phosphorus leaching into rivers. So either way, it's not a good thing. So there's a growing realisation we actually need to be applying we need to apply these manures as a phosphorus source, and then you can either cut back your nitrogen that you apply on top, and the other elements you can just use as a bonus. So we need to actually use a phosphorus balance approach when it comes to manures. So the question that the farmers then ask is, well, if I want to put on 15 kilos of phosphorus in my crop, and I'd normally put that on as MAP or perhaps superphosphate, can I just put on 15 kilos of phosphorus in the manure? Are they the same thing? We've heard that it's a slow release form of nutrients. And that's kind of true, but it's also kind of not true. So for nitrogen, for example, it probably is a slow release. Well, it almost definitely is a slow release form of nitrogen because nitrogen is inherently linked to carbon. And so the release of nitrogen will be related to the degradation of the carbon. But then you take something like potassium in the manures, well, potassium is not really linked to anything. So that potassium, as soon as it rains, will become available. So you get some elements or nutrients that are highly available and some like nitrogen that aren't, that are going to be slow release. And the question is, where does phosphorus sit among all that? So a reasonable proportion of phosphorus in manures can actually just be inorganic phosphate. So that's going to be pretty available straight up. Right at the other end, you've got things like phytate. So phytate, say a wheat crop and other crops, they take up phosphorus from the soil and they store that in their seeds as this organic form called phytate. We can't digest phytate. That goes straight through us and into our feces. Monogastric animals can't digest it, so it ends up in their manure, and ruminants can partially digest it. There's also phytase enzymes added to a lot of feed, so you might get a bit of decomposition of it. So on the one hand, you've got inorganic phosphorus, then you've got phytate possibly, at the other end of the spectrum that's very slow to degrade, and then there's all the in-between, so DNA, RNA, ester phosphates that sort of turn over pretty easily. So question is it slow release or is it not? So the first thing we did was conduct a meta-analysis, which is where you draw in all the data sets you can find, where people have compared mineral fertiliser to manure as a phosphorus source, and you try and tease out, all right, which is better or what might be driving why one is better than another, whether that be a soil type, the type of manure used, etc. So I pulled together all the data, but then hit a problem in that I have a pretty limited skill set and meta-analysis and crunching data isn't really in that skill set. But luckily, we had a new employee turn up at the university, one Associate Professor Michael Rhodes, who I asked very politely to run a meta-analysis for me. I said, Mick, you human turd, run me a meta-analysis. And he did. And that's what you can see on screen there. And so I'm going to take a bit of time to explain what you can see there. And it's one of the more interesting findings from that meta-analysis. So on the y-axis is time. So there's a range of, all sorts of studies. Some people have grown crops, some people have grown ryegrass, all sorts of things, and they grow for different lengths of time. And what we thought was, well, if you grow something for a short time, that doesn't give organic phosphorus much time to degrade. And so we sort of thought, all right, well, some of these short-term experiments, possibly the synthetic fertiliser will do better because that organic phosphorus hasn't turned over. But once you get to a certain length of time, presumably it's degraded and they might be on parity, which is actually what happened. So as complex as that looks, basically where you can see, if you look at the top graph to start with, this is where crops were grown for over 100 days. There's a little dot with a red line in the circle that shows the mean. So that's the mean, and the line you can see up and down is the parity point. So it hits 0 at the x-axis. What that means, anything to the right-hand side of that means that your manure was actually a better phosphorus source than the inorganic fertiliser, right? So if you're to the right of the 0, that means phosphorus was good. So your top graph, once you grew things for 100 days, the phosphorus in the manure was as good as a synthetic fertiliser. So because of the error bars, you can't say it was better. There was no difference. Ditto for the middle red circles, 50 to 100 days, phosphorus from manure was just as good as the synthetic. Whereas down below, if the trials were grown for less than 50 days, then the manure phosphorus was not as good as the synthetic fertiliser. So in other words, we think there's probably some organic compounds in there, maybe your ester phosphates, RNA, DNA, that take a bit of time to degrade. And because of that, it's not as effective in that short term. But anyway, at least that gives us a hypothesis or something to work towards that we can at least test. So beyond that, Mariam Barati is our PhD student. She's actually run some dose response curves where it's a typical phosphorus response curve. You put on multiple rates in a particular soil type, you generate a yield response curve. So what you can see there is the response of wheat, grain yield response of wheat to different manures and MAP, which is a typical source of phosphorus that farmers use. Two things. One is the critical value for the manures, other than chicken manure, was as good as the MAP. And the second thing is you can see the yield potential. So if you look at the y-axis, the yield potential was actually better for the cattle and pig manure than the monoammonium phosphate. So at least in that particular sandy soil, the manures were as good a phosphorus fertiliser source for a wheat crop that took about 4 months as synthetic fertiliser. So it looks like these things are, at least for grain growers, you can pretty much use them at parity. The reason the chicken manure takes a dive and its curve plummets, if you look at the graph below that, it's actually nothing to do with phosphorus. Manures have got a lot of other things in them, and what you can see in the orange on that bottom graph is the concentration of sodium in the wheat leaves. And once that chicken manure gets above about 6.4 tonnes to the hectare equivalent, all of a sudden the plant can't handle, or the roots can't keep out that sodium, and it's sucked up too much sodium. So the reason the wheat yields declined at high phosphorus loads was nothing to do with phosphorus. It was a sodium toxicity, and that's going to happen at times. And there's ways around that. You could put the manure out a bit earlier, let it interact with the soil. And it also, Mariam's conducted subsequent experiments with other soil types. It didn't happen on soils that have a bit more buffering capacity. It was a special with the sandy soil that we used on this occasion. Finally, we all know nothing works unless it works in the field. So we have 2 trials in this year. One is at FarmLink. So Hayden Thompson set up the trial you can see there with all sorts of plots, and he's kindly put some treatments over the top for us. He took a drone shot. So that's it growing about a month ago. And on the right-hand side is a field trial we've got at Wallingbar on a ferrosol. And the reason I show you that one is because you can clearly see that, like all good ferrosols, it shows a great phosphorus response. So we're confident that we'll get some data out of that one. We don't have the data yet, but you can rest assured that as soon as we do, you people will be the first to know. And I'll leave it there. One final thing though, sorry, I did forget to say, before I end, I always enjoy coming to these conferences. They're a fantastic chance to meet the students, to meet everyone. And once again, so to the people from the Soil CRC that have taken the effort to organise this for us and put it on, thank you so much. You do a great job every year. This year's no different. And yeah, thanks very much.